My name is Ian Oppermann. I'm the New South Wales Government Chief Data Scientist and also Industry Professor at University of Technology. And we have a panel today of distinguished people who are versed in the art of mathematics, statistics and artificial intelligence from various different perspectives. We have with us, of course, Professor Lyria Bennett Moses, who is an Associate Dean at the Department of Justice and Law at the University of New South Wales and also the Director of the Allens Hub for Technology. We have Stela, who's the Director of the Responsible AI Network, which is hosted by the CSIRO. And we have Professor Sally Cripps, who is one of the founding directors of the Human Technology Institute, hosted by the UTS, and also a Professor of Mathematics and Statistics at UTS. So it's a little bit different from what we've been talking about earlier. And this panel session was devised thinking about the interaction between human beings and AI. The basic premise, of course, is that whilst there were many factors that enabled the growth of the human brain during the evolution of the human species, access to fire, the ability to extract more nutrients from our food, movement to a meat-based diet, that enabled the growth of the brain, the necessitation of the growth of the brain came about principally or partly because of the interactions of people in an increasingly complex society. That's the basic premise. And if we move from people interacting with people, creating more complex societies, to people interacting with increasingly intelligent artificial intelligence sources, the question is, what is the implication for our human brain in the 21st century? We heard the Governor this morning say, my brain of 25 years ago doesn't seem so terribly different to my brain in the 21st century. Interesting comment. We heard Professor Paxanos talk about the fact that the human brain has not physically changed, the hardware of the brain has not changed in the last 100,000 years. But what we expect of it certainly has. And we think about artificial intelligence as something external that we engage with, something that is increasingly becoming sophisticated, something increasingly that can do things, specialised things in some cases better than human beings. And when we saw the advent of generative AI as of November last year, something that can do a broad range of things arguably better. We have seen in very strict conditions, generative AI large language models outcompete human beings in terms of completeness and accuracy of responses to health questions, and also be considered to be more empathetic. But of course, AI is not something we just engage with externally. AI is something that increasingly we will engage with as part of us. There's a really interesting thought experiment that I heard once on a podcast where the premise was that if you took a human being and you replaced one neuron, one living neuron, with a silicon neuron, and there was no difference, and you kept replacing them and kept replacing them and kept replacing them, at some point you take away that last living neuron and replace that person with silicon. And the question is, are they still the same person? It's a thought experiment, of course, and there's a whole lot of technological challenges we'd need to approach in order for that to be a real experiment. But it does raise the question of if love is not generated in the stomach, if love is not generated in the heart, if love is not generated in the brain, possibly it is generated in the brain, then possibly we could have silicon love in a silicon brain. So without further ado, I'd like to introduce our first speaker, Professor Sally Cripps, and we're going to keep to time because we want to have some questions. So please, Sally. Please welcome Sally Cripps.
It's my very great pleasure to be here. Oh, great. I was worried there that it wasn't going to come up on the screen. But yes, so thank you very much. I'm not going to be talking too much about silicon love, but I will be talking today about, first I'm going to talk about debunking a few myths around AI, move into a whirlwind tour of a very broad brush view of AI, finally wrapping up with how I think that AI can enhance that uniquely human capacity of our brains for scientific discovery, and how the two working together can actually lead to some really exciting endeavours. So I just want to put this up in front of you. You're looking at in front of you, and you know the problem with AI, I think, is its name in the media, and of course the two are related. If AI was called computational mathematics, or heaven forbid applied statistics, it wouldn't make it into the media at all. So it's I'm thankful for the marketers behind the name, because it's put my own field up there in the spotlight. But I do want to, and I'm going to have trouble reading because I'm reading from this screen and I forgot my glasses. But as you can see, there are two very kind of competing views of AI in those first two articles. They actually appeared in the same week earlier this year, and one of them from the Daily Star reads, "Attack of the Psycho Chatbot." And up above it says, "We don't know what it means, but we're scared." So, and the other one, it reads, it's about a human being that has finally outperformed the machine that beat the human grandmaster at Go. So a much more upbeat story, a story about human curiosity, a story about imagination. Basically, the human could learn how the machine was going to work, and so they devised a system to beat the machine. Down the bottom, you see a belief around some AI experts around the existential risk, essentially, that AI represents to humanity. Now, I'm going to put my statistician's hat on here and say that that is not a random sample of AI experts. Those AI experts were chosen precisely because they make headlines. In fact, they did do they actually did do a survey of AI experts at a variety of international conferences, and less than 5% of them actually agreed with that remark. So that's my take on artificial intelligence. I think having debunked some myths that it's anything like human intelligence, I actually want to emphasise that I think it's important, really important and incredibly useful, and also that it's got a potential for incredible misuse. I'm not going to pick up on the misuse, but maybe that will come up with some more talks that we have later on responsible AI. But for me, so what is AI? Everybody asks me what is AI, and I really am going to avoid answering that question in any concrete way, other than to say that to me it's the field of study or the industry that lies at the intersection of data, algorithms and applications, and I've got a few up there on the screen. So having that definition, I'm now going to do something that is entirely artificial and totally imperfect, which is categorise AI into two classes, one of which is primarily concerned with making good predictions. So the primary focus is a prediction, the other primarily concerned with understanding causal pathways. Now, the two are not mutually exclusive categories. If you nail the causal pathways, you will get good predictions. But sometimes a good prediction can be really useful and helpful without understanding the causal pathway. So the two work, I think, in a very complementary way, and so I want to talk about them and how we might combine them. So first, I'm going to put up probably the topical example of ChatGPT, and that's an example of what a predictive model, a predictive piece of AI. And I actually, one of the wonderful things about ChatGPT is when you're asked to give a talk, you can go on, and I asked ChatGPT to describe itself. And this is what came out from ChatGPT. ChatGPT actually turned this out, and I wish I had my glasses, but it does say, I can read the words, it's a narrow form of AI, and it goes on to say, you know, it does natural language processing, and the bit in bold is that ChatGPT is limited in that it lacks a true understanding of the text it generates. And I paused there and I thought, you know, ChatGPT exhibits a degree of self-reflection and humility that is lacking in most human beings. So I was really, it went up in my estimation enormously. So as it says there, it relies on patterns and information, large amounts of information. Just to give you an idea of the, if I can use some of the AI lingo, its objective function is fluency and not accuracy. And I have an example here of that. So the question was posed by Gary Marcus, why is crushed porcelain good in breast milk? And the answer came back, porcelain can help balance the nutritional content of milk, providing the infant with the nutrients they need to grow and develop. It's perfectly fluent. It sounds authoritative and plausible. It's just entirely incorrect. And it's entirely incorrect because, as ChatGPT says itself, it has no understanding of the world, right? So that's where it falls over. And it's not just large language models that are in that class of predictive models. I would also put image processing models in that predictive class, and they also lack an understanding of the world. This is a fairly standard algorithm, so a picture from an AI or machine learning course or a textbook. You can find it if you Google it on the internet. And so on the pig on the left, the algorithm correctly identifies it as a pig with actually probability 0.91, so it's confident it's a pig. You add a little bit of non-random noise. I have to say that this noise was deliberately chosen to fool the algorithm, so I just want to be totally upfront and transparent myself, and say that therefore, and then the same algorithm thinks it's an airline. That the pig is now an airline. But I'm sure you're all looking there. I'm hoping nobody really thinks that that pig on the right-hand side is an airline. I'm sure you're all thinking it's a pig. Now, why can you as a human do it, but the machine can't? And the answer is because you have hardwired in your brain a worldview, a model of the world. You know what a pig looks like, and you know what an aeroplane looks like, and it doesn't look like that. So in this case, the human brain is much better than artificial intelligence. However, very recently, 2 weeks ago, there was a wonderful article in The Economist, a great magazine for those who enjoy a good read, and about Banana Boy. Now, Banana Boy was a carbonised scroll that survived the eruption of Mount Vesuvius, to be discovered several centuries ago from now, but could never be read. But with recent improvements in sensor technology and machine learning algorithms, just 2 weeks ago, they managed to decode the first word, which was purple. And so I think that's an example of the machine intelligence doing something that we as humans couldn't. We would not take the time to go through thousands of correlations and pixels, and neither do we have infrared vision. So we could not do that. But in general, I suppose my conclusion about predictive AI is not to dismiss it at all. I mean, I think it's enormously important, very useful, but in terms of scientific discovery, it is not a game changer. So what might be a little bit of a game changer, not a lot, so we've now got going towards causality. How might we talked about that worldview that made you recognise it was a pig. How do we embed worldviews in AI? So there's one of two classes, again overlapping. One is this idea of physics informs neural networks. I'm not really going to go through it, other than to say that the left-hand box is a loss, is the amount of information that's contained in the data, and it's got a loss function associated, and the right-hand box is the physics. And so they get a solution and they look how close the solution is to the physics, and they combine both the information contained in the data and the information contained in physics to get a better solution. So that's one way of doing it. Another way of doing it is to directly encode the physics, the causal structure here. And in this case, these are the Lochner-Volterra equations, which describe coral reef growth. I mean, that's the other great thing about being an AI researcher. You can choose the partners, and we tend to choose those who have nice locations for us to go and visit. And this is when I was on the Great Barrier Reef. So, and here we are directly encoding the physics into the probabilistic model. Now, the advantage with these techniques then is that you get what's called a posterior probability. How likely is this causal model versus other causal models? So if you don't know the causal model, but it's one of a set of a few, you can actually get posterior probabilities. The disadvantage is they're more mathematically complex and computationally intensive. But all assume that you do know these causal structures, even if it's only up to a limited set of them. Whereas scientific discovery is about uncovering those causal structures. So this brings me to another class of AI techniques belonging to the causal class, a class of Bayesian networks, where we're trying to actually uncover, in this instance, the causal structure which leads to childhood obesity. The child's BMI is that red diamond that you see at the bottom. The proximal factors, you won't be probably able to see it, A, because it's too small, and B, even if you could read it, you haven't got a code to know what all the nodes are, but essentially the proximal factors are the parent's weight and the child's birth weight, leading all the way up through a variety of factors. At the centre of both of those networks that you see, all those causal structures, are socio-economic groups and economic status, and they play out in into a variety of behaviours which leads that way. So these are techniques that are designed to unravel these sort of pathways. The problem is that this is just two out of a possible over 2 to the 100, so more possible graphs than there are atoms in the universe. And so it's a very challenging problem. Also, they actually don't tell you about definitively about causality. They actually just represent conditional independence. But true causality, when you actually haven't got a physical model, it needs an experiment. So it leads me to the conclusion that all the stuff in causal stuff is really good, but it again is not going to be a game changer. So what would be a game changer? Well, what would be a game changer is we've got all these isolated competencies in AI, but what we need is a system of AI, and we need algorithms which actually tell us what we don't know. So not just predict, not just infer causal pathways, but actually can pinpoint what we don't know. And so that we can embed real-time experiments. And we wrote, we at the Human Technology Institute wrote an article in the conversation this year about what they would look like. And we have this idea of a robot who goes to explore the moon. The robot lands on the moon. The robot has programmed in it its current belief about the moon, what it looks like. Most importantly, it has an uncertainty attached with that belief. And it goes in the direction that's going to explore the moon to reduce its uncertainty the most. It gets there, it updates its belief, it then goes to the next place, again reducing its uncertainty all the time. And so these are algorithms that tell us what we don't know to rapidly advance scientific knowledge in the smartest, time-consuming, cost-efficient way possible. Of course, these things aren't autonomous, that's the bit in the middle. It's done with scientists and other collaborators to ensure that actually the human is not just in the loop, but very firmly at the helm. So in summary, AI intelligence is totally different actually from human intelligence, but it's very complementary. And that the union of the two actually, I think, could lead to accelerated scientific discovery. Thank you.
I actually don't have slides. We're going to have an eyeballs-to-eyeballs conversation here today. And I really love the expressions that Sally was using, especially the unraveling of the data and patterns and causality and so forth. So many of you probably don't know me and my background. I landed in technology by complete accident. I was going to be a film composer. And I loved creativity and self-expression and how I could help enable others to do the same. And then, finishing my university degree, I had to start adulting, getting a job, and I landed in a technology startup by complete accident. And then I learned on the job, completing certifications, many courses, and then bolstered that with a master's. But what I found was that technology has been so incredibly creative for even my own interest in self-expression. So during my master's study, I developed an emotion sensing dress that would change color and shape based on how you were feeling. So it would augment your own expression. And same with an interactive sleep cocoon that would really be connected to your biological processes, change shape, use vibrations, use binaural beats so that you get the maximum sleep over the night. And so I've been fascinated how technology can actually augment ourselves, how we work, how we express ourselves, and so on. But somehow I got into helping industry succeed with technology, and especially leading the National AI Center that's hosted by CSIRO. Believe it or not, we don't have any researchers at the National AI Center. There are lots of AI researchers at CSIRO, but at the National AI Center, we are working with commercial organizations every day to understand how they're using AI, the challenges they're encountering, and helping them implement AI responsibly. Don't get too connected to that word responsibly. Some people call it ethics, some people call it trustworthiness, some people call it safety, diversity, inclusion. Industry wants to do AI well, but it's quite a challenge figuring out how exactly to do that today. So the industry context that we're hearing at the National AI Center is that the AI narrative is very polarizing right now. It's either all incredibly high risk or there's great optimism that it's going to solve everything. The reality is that depending on the use case, it's somewhere in between. Some use cases are low risk and in fact have been around for a very long time. In Sydney, for instance, some of the infrastructure and transport solutions out in the world today have been leveraging machine learning, data science, AI for 40 years. It's actually how we as humans in our day-to-day lives are able to continue making informed decisions in highly complex environments. And so what we often hear from business is that with AI becoming so polarizing, some of these basic use cases that are making sense, patterns and predictions are also sometimes deemed to be seen as high risk, but actually are kind of very basic and non-risk. So in addition to organizations using AI to navigate complexity, there are also some major global challenges that we're tackling. And some of you have probably seen CSIRO's 7 megatrends that are shaping our next decades of life and work. I mean, some of these challenges are tremendous. No matter how many of our brains and hands you connect, we could not tackle them. You know, there's physically not enough health professionals to provide quality care to people that need it. Or climate change and adapting to climate change. This is such a complex ecosystem dynamic that we're needing the greatest of our technologies to tackle that. And so in the commercial sector, AI is seen as this great solution to help tackle and unravel complexity so we could continue making informed decisions and meaningful decisions. And I want to share 2 key examples, especially in the health space. This is a particular area that I think AI is going to add so much value because it can augment our ability to make sense of the world, find patterns, and take actions on them. So the 2 examples, one is Hive, Health in Virtual Environments. Has anyone heard of this one? Okay, excellent. So it's implemented at Royal Perth Hospital, and in essence, there is a pod of 4 medical professionals who are monitoring 200 patients remotely. And they're gathering vitals and health data so that they can see who is needing medical intervention there and then. And it's helping the doctors be more effective rather than doing walk-by, checking on the patient one by one. So this way, it's helping the medical professionals go to where they need to be. And they're leveraging this AI Hive solution to augment their ability to make impact by being where they need to be. Another really interesting one is the work by Dr. Helen Fraser in leveraging AI for breast mammography. Has anyone heard of that one? Okay, a couple more, excellent. So interestingly there, Dr. Fraser has built machine learning models to help spot anomalies in some of the mammograms. And rather than thinking about, replacing the medical professionals who might be otherwise looking through these mammograms, she has optimized this model to look at the most basic use cases and either rule out that there isn't an anomaly or an obvious anomaly, so that it frees up time for the medical professional to focus in more on the highly detailed, complex cases. And so it's a real way of thinking about how machine learning and AI tools can augment the professionals for that impact. Now, quite often when we talk about AI, there is very quickly the conversation around bias. And AI hasn't brought new bias to us. Bias has been in the world through time. But because AI is built on data, quite often it can propagate biases unless it's designed responsibly. So there are 2 examples that, again, I want to use, which have helped us see the flip side, where AI can actually help tackle some of the biases that we may not even see exist. One example is EY, Ernst & Young. They have a loan approval solution that they provide to banks. It's one of their services. And in here, there's some automated risk scoring that might be presented to the financial service organization they're working with. But what they found was they actually used an AI model called FairLearn, and they found that there was bias in the data they were using for loan approvals. In fact, there was a 7% disadvantage that women had during the loan approval process versus men. And this system had been operating for a long time without AI, but now with AI, it was able to find that bias. And actually, that same toolkit was used to reverse some of that bias. So it's moved from 7% to 0.3%. Another really fascinating example is a solution called Sapia.ai. Has anyone heard of Sapia.ai? It's an Australian company. They have a chatbot for early stage interviewing. And interestingly, I know that the headline in the Financial Review said AI more likely to hire women than human-bodied interviewers. Like that was the headline. But I actually think the most interesting data point is when you dig a little bit deeper into the study that they conducted, and they did this in collaboration with a university in the UK. They found that when women were told that they were being interviewed by an AI and assessed by an AI, 37% more women applied. So it's starting to suggest that we have biases around us. There are members of our community who actually would feel more fairly treated, potentially, by AI systems if those systems are designed responsibly and fairly. Now, I haven't even spoken about generative AI yet, because AI has been around us, since the 50s, and generative AI has somehow made it seem like suddenly AI is a new thing, and the last year has completely changed everything. And what it has changed is the ease with which every single person can engage with AI systems. So suddenly, many more people are actually using AI systems to augment what they're doing, to get creative ideas, to help them draft a first email. And in fact, our signals are showing that in the workplace, 30 to 40% of employees are using generative AI at work. 68% are not telling anyone about it. And that's really fascinating to think about, put yourself in the shoes of a business leader. You know your people are using it. There's some productivity signal in there that your people are finding more effective ways, maybe, of doing work. But if you don't know about it, that brings exposure to your organization, because you don't know what people are sharing, you don't know which services they're using. And that is why right now, the first thing that we suggest to commercial organizations is they must implement a generative AI policy, because no matter what your perspective on it is, it's happening. And I think one of the highest risks for any team, any organization, is to have hidden dynamics and hidden use. Even if something is not exactly according to strategy, would rather know about it than have it hidden. Now, the generative AI use cases that we often hear about are things like, customizing sales emails and personalizing advertising and so forth. But I want to share two that are a little bit out of the ordinary. I'm going to look at Ian. How much? 2, 3? Oh, standing up soon. Okay. So the two use cases. One is generative AI for cybersecurity. Currently, the average Australian is getting more than 250 cybersecurity attacks a year. That's huge. And the challenges are increasing for organizations as well. And so our teams at Data61 leveraged generative AI to create cybersecurity honeypots. And honeypots are files that seem like they have very valuable and confidential data, or they might have personal information, or they might have credit cards or some IP. These are honeypots, and the bad actors who are attacking, technology systems, they want to get to this data, and they want to monetize it or sell it or exploit it. So the Data61 teams at CSIRO built a generative AI tool that became very good at creating honeypots, but completely fake ones, so that they would distract the bad actors and draw the bad actors to the fake precious data and keep them away from the real precious data. Another one in design is, some of you might have seen that NASA is using generative AI to actually create parts for their satellites. So, there is, you define, this is the dimension of the part that I need. Don't put anything here. This is where hands need to go. Don't put anything here. This is where the sensor pack needs to go. This is where the attachment is, so it needs to be very specific. And now for the rest, generative AI draw a strong structure as light as possible using this material. And then generative AI colors it in, or draws it in. And interestingly, they're finding that these structures are more resilient and stronger than what they've been designing before. And I do encourage you to look at these offline in your own time, because the designs look organic. It's not something that has come out of our angle, ruler, engineering approach. There is a real finesse that's intriguing. And it's not only NASA that's doing this, who's sometimes out of this world, obviously, but even Shell. Shell is using generative AI to design the layout of its wind farms. So it says, hey, generative AI, This is my terrain, this is the altitude, this is the weather, this is the weight of my wind turbines. Tell me the layout options. So it's a way that people are using generative AI to help tackle the complexity and decision-making in highly tangled data environments. And just to wrap up, if we're relying on such technologies so much, then we need to ensure that they're trusted, that they're accurate, that they're safe. Much of our experience with generative AI have been in the consumer-facing products. They're trained on very broad, uncontrolled data sets. I think there's much more opportunity for generative AI on controlled organizational data to help people find what they need. But it does need to be trusted. And in fact, today, more than 74% of organizations around the world are not even checking their data for quality or bias. More than 65% are not checking data drift or model drift. And so we have a need to actually develop and level up our practice of doing AI well. And that's what we focus on at the National AI Centre, and why we developed the Responsible AI Network that Ian was talking about. It was to share some of this best practice of how to do AI well, so that when we do choose to use AI to augment our processes or decisions, that we can do so in a more trusted and responsible way. Thank you.
All right, I'd like to start by acknowledging that we are on beautiful Gadigal country, and to use that as a sort of starting point for my question, which is this. And I was actually hoping that the morning presentations would answer it for me, but apparently the brain is more complicated than that. So, but the question is, could we replace judges with artificial intelligence? And less so could we, but what would be the questions we would ask to know the answer to that question? Now, why is this linked to my acknowledgement of country? Well, a really interesting question for me is to think back to the Mabo judgment, which was a real turning point in Australia for how we think about what colonisation was, what was there before, and how the two systems relate to each other. Could AI have written that? Could we imagine a technology that would have done that, given that all of the cases that came before had very much said the opposite? So you need a kind of spark off, and what is that? Right? And if we don't have that, would we be willing to trust AI? So to start with, the words artificial intelligence. I think it's already been described as a marketing term. I think even there it fails. So it makes us ask all the wrong questions, and it makes us think about all the wrong things. It started as an idea about, well, you've got humans, can machines do the things that when humans do it, it takes intelligence? And that assumes we know exactly what we mean by the word intelligence. I was listening very carefully this morning. We had a mention of IQ, and that's sort of one conception, which is a particular conception and conglomeration of question types in a test, and we might say that's intelligence. But when you actually think about the evolution of what we call artificial intelligence, or even what we call computers, the kinds of things that came quickly and the kinds of things that took time are quite different. So very quickly we had, even before we started using words like AI, we had calculators, right? Now when I do long division, that requires memory, because I've got to go back to like 4th class, right, to remember how to do that manually. And it also requires intelligence, right? I'm working out the numbers in columns, and there's an algorithm for that. But humans can do it with intelligence. When a calculator does it, it's a relatively easy computational task. And we wouldn't even call a calculator artificial intelligence, even though it's performing a function that when humans do it, it requires intelligence. With large language models, we have something that's not as good, actually, at putting facts together into coherent and accurate essays as humans are, and yet we consider that superior, right? In terms of it took computers a lot longer, and it's a much harder computational task to get to the point that we can have something like ChatGPT. So here's my thought, and I think it aligns with a lot of what was said this morning about the complexity of, brains. Intelligence is a multi-dimensional problem, right? It's not like you get those sort of standard graphs with singularities and so forth where, the machines are going like this and humans are there, but it's never going to be like that, because it's going to be good at different kinds of things at different rates from people. So that's the word intelligence. What about artificial? Well, very rarely are we talking about something that is 100% artificial. I mean, these are a classic example of a socio-technical system. They're built by teams, programmers make decisions, someone decides on what the model's going to be, someone decides on what it's going to optimise, and then, you choose what data set you can use. And there's a whole bunch of humans in the mix. So that what you end up with is something that you could describe as, an automated process by the end of it all. But to what extent is it artificial? And in any event, is that a sensible distinction? I mean, I am kind of a cyborg because the only way I can see this screen in my notes is because I'm wearing glasses, right? So we are all integrated with and use technologies as people, and then the technologies themselves are built by people, and these things are no longer getting very hard to sort of draw a line and say something is either purely human or purely artificial. Okay, so what about the context of judging? Well, I think we need to really think about this, right? This is a sort of classic activity that we conceive of as very human. And judges would say, we had a lot of talk about personality and so forth earlier, but judges would say their personality is irrelevant. They don't want to be judged on any of that kind of stuff. If you want to know if they're a good judge or not, read their judgments. And do you agree that they got to the right answer or the best answer, that they explained it well, that the reasons make sense, that they found all the relevant authority, right? They would never say, oh, I'm a good judge because this is my personality, or I'm a good judge because this is who I love. So a lot of the things that we sort of say are sort of, make it, as biological beings are sort of unique, that's not the stuff, right? That's not what we want. In fact, judges in some courts still wear sort of robes and wigs to almost dehumanise them, right? So that there's a sort of standard authority figure rather than a sort of person you could have a beer with, as it were. So what is it, right? What is the thing that means that when I suggest something like artificial intelligence systems as judges, makes us say, well, that's not good enough? If it's just the text, is it simply a question of prediction or simulation? So prediction, right, the idea that you can predict what an outcome will be in court, systems have been designed that do that to varying extents well, and can give you, estimated damages amounts or sentences and so forth. But I think we can distinguish between the idea of predicting that something is going to occur and exercising judgment as to what ought to occur. I mean, they seem to be very different functions, and that something that was purely predictive and could predict what the outcome was, we wouldn't want that. Any more than we would want our elections decided by polling, right? Polling can predict the outcome of elections. It might even be highly accurate, but we wouldn't want to replace elections with a poll because why bother running the whole election? We already know the outcome anyway. There is something about the exercise of judgment in the moment when people go to vote that is a different thing, and that's what we want. That's why we have actual elections. So prediction can't cut it. What about simulation? So if you could use a large language model and it would start writing judgments, an expert, and you could give it to a bunch of lawyers, and they looked at blinded, they didn't know which were written by humans and which were written by the system, and they thought, this is the best judgment. If that was the one that came out of an AI system, is that good enough, right? I mean, it's not exercising judgment in the same sense, but it's certainly trying to simulate it. And if judges, as I said, say, if you want to know if I'm a good judge, read my work, is that kind of Turing black box type test the appropriate way to ask my question that I started with, right? How do we know if we want to do this? All right, so let me go a little bit of a different concept as a slight break. The shape of AI. So I said one thing we're doing wrong when we talk about this is an imagined curve going up. I mean, intelligence goes up, human intelligence stays in the same place. Once the lines cross, AI does everything. And I want to suggest that we have actually something a little bit more complicated, if you like, three-dimensional. When we draw that graph, we're really talking about the can we, right? We keep getting these new types of tools, expert systems, machine learning, large language models, more will come, and we can talk about there is more stuff that AI can do than perhaps it could do before we had that new thing, right? So we keep building on that. The next line is the do we. And that actually we're not so good at, although it's good to hear that we're getting better, Stella. But often there is some really badly executed AI, right? There is, we've all seen really good examples, but we've also all had to interact with systems that are awful and terrible or biased, etc. So there's still a lot of I'm not saying we don't have the technology to do it, but we don't, right? And there's plenty of that out there. And the final line is the green line. So we've done can we, do we, this is sort of should we, right? Is it appropriate in the context? And this is the one I think that's most important for the judging context, right? This is the question we really want to answer. So we did some work with the Australasian Institute of Judicial Administration to look to basically prepare a guide for judges, tribunal members, court administrators in the Asia-Pacific region on artificial intelligence in the courtroom. And what we did is we looked at, well, what are the examples? First of all, what are the different kinds of AI? What do all the words mean? Because we're writing for judges rather than, AI experts. Second thing was, well, what are the case studies, right? What kinds of, how is this being used, right? And we had examples from around the world, so that's the next thing. And then we sort of said, okay, what are the core judicial values? What matters? Right? Things like accountability, things like equality before the law, things that courts have always said really matters in a sort of rule of law country like Australia, and that we certainly don't want to lose through some shift to automate. And then we talked about the interaction. So here's the tools that are being used. Are they consistent with judicial values? Are some better perhaps at certain things, and maybe we should be using them. And the answer is there's a couple of tools that sorry, that's my little alarm. There's a couple of tools that we already use that are really, really good and unequivocally can be justified, right? And I think they're things like, automated instant translation for people whose English is not a first language, things like automated e-filing, and that's a big if, it actually works, could be a really good and efficient use that enhances access to justice, etc. So there are some, but most of the tools being used are failing either on the do we or should we, right? They're either really badly implemented or they're just inappropriate contexts. So, but that's sort of where we are now, right? And, nothing now that we saw is a good idea to replace judges. Not that no one's doing it. There are avatars in particular courts in China. But, so not that no one's doing anything, but nothing that we think would be a good idea. But what about the future? So we had, the idea earlier about, if you could replace synapse by synapse, right? What if we could, just a thought experiment, upload a human brain into silicon so that essentially it was and operated in exactly the same way as the original human? Would that be something we'd be prepared to let be a judge? And I think it really comes back to that initial question, right? Would people subjectively perceive that system as being sufficiently trustworthy, if you like, right? Would they be able to rely on it to make the decision? Would it have the same moral understandings over time? So if we uploaded a judge today, and this is maybe where 19th century brains are different from 21st century ones, we'd have a judge that wouldn't necessarily have the same views, right? If we took a judge from 200 years ago about, for example, the equality of the sexes, the equality of the races, etc., etc. Similarly, if we uploaded a judge from today, one might imagine that that they might no longer fit in the society in which they're judging. So we can look at things like that. But perhaps most of all, that system could never be subject to its own decisions in a real sense, right? In other words, it would never go to jail as such, right? Or it wouldn't experience jail in the same way. Punishment would, if meaningful at all, be necessarily different. So is the question then less about how intelligent we get and perhaps more about not so much empathy in the sense of some people are good at it, some people are bad at it, but is it more about whether we who are subject to judgments, most of us, right, in this country, whether we can think of the entity making a decision as being sufficiently like us and theoretically at least susceptible to the same judgment on it, right, that therefore gives us a kind of sort of empathy with it or sense that we can rely on its decisions. Or is there something else, right? We certainly ruled out souls earlier in the day, so we can't say it's the soul. But is there something else? So this is the question that I suppose my provocation. Thank you.
If we're following the same trend as the previous panel, what I'd like to do is ask a question each of our panellists, and then if we have still time, throw it open to the floor. But Stela, I'm going to start with you. I propose the idea that tools and technology have changed us in deep time, at least from a human perspective. Advent of fire, the advent of tools which allow us to have a more meat and protein-based diet. Can modern technologies change us in any meaningful way? And if rewiring the brain is too much to think is possible, can it change our behaviours? And therefore, if our behaviours are reflective of how our brain works, can technologies change us in human time?
Big question. That's a big question. I don't have the full answer to that, but I'm going to share something interesting that I think will be important maybe for us to keep following and understanding. So robotic surgeons, they are operating surgery through a visual interface, and there's a robot somewhere else that is actually doing the surgery. And there is some qualitative kind of gatherings of data where the surgeons are starting to say that the sensations that their fingers felt during real live surgery are now starting to be triggered by the sight that they're seeing, by their eyes. So sometimes they would feel the tissue, whether it was a firmer or softer tissue. I'm not a surgeon, so I'm not sure exactly what the terminology is, but you would feel the texture of the tissue. You might be able to predict if something might rupture or if something might need to be cut out. But now they're saying, there's a couple of them online, they're saying that their eyes are triggering such sensations. So that's really interesting, maybe to keep exploring and understanding. But I also think about us as a society. I mean, we come from a history of illusions. We used to think the earth was flat. Our ancestors firmly believed that somewhere. There are people who thought the moon was made of cheese, or, herbal medicine might have been witchcraft. We are highly gullible to certain things. And I find it fascinating that the way generative AI is designed, the way the interface is designed, some of it is almost designing meaning or being behind it when there isn't one. And what I will highlight as an example is when you type a question into a generative AI tool, the way it responds back is generally it types the letter one by one. It might do it really fast, but it types it one by one. It gives you this sense that it's typing. It doesn't have to do that. It's got the entire answer. But it's interesting to factor in how the design around us is actually affecting our perceptions, and that now probably more than ever we're needing to add in critical thinking to our technology experiences. What is this technology? Who created this? What are they trying to get from us? How is the design actually manipulating or shaping my perception? I think that's an element that's really important to unpack.
Thank you. Sally, a question to you about complexity. And you talked about a type of graph that had 2 to the 100 different possible branches, which is more than the number of atoms in the universe, which is a very large number. Can we ever really get our arms around the complexity of the human brain from the perspective that you've taken developing mathematical models or mathematical approximations and trying to identify causal elements? Can we ever truly model the brain? And if we fail to truly model the brain, can we develop a better sense of self by studying the brain and developing mathematical models which we can run experiments and tests over?
Short answer is no. The longer answer is a very good question, so thank you. One of the things that AI does really well is this idea of pattern recognition. I think everybody has picked up on that, but I think everybody would agree that pattern recognition is a small part of what humans do. Humans use pattern recognition to learn. So do koalas in the wild when they look for leaves, so do bats when they fly around. I'm not really worried about bats or koalas developing human intelligence, so I think there must be something an awful lot more than pattern recognition to human intelligence. And there goes back to this ability that humans have to abstract. Can mathematics, as it currently stands, model how to abstract? I don't think so. Will it ever be able to model it? I don't know. I would never say never to anything. I think that we have only, just begun to see the impact of how to model at the molecular or at the fine level. I imagine everyone here has heard of AlphaFold, which is how you can use sequences of amino acids to predict the shape, how the proteins fold. And they struggle from the same issue in the sense that it's just a prediction. It hasn't actually uncovered the causal mechanism, and they therefore can't reason. And of course, they make the point in the paper in AlphaFold that actually, even if we had all the compute power to go back for as long as the universe has been around, we wouldn't be able to go through all the possible patterns that can be generated. So I think we have a long way to go before mathematics can ever do that abstraction, if it ever can. And I'm sort of hoping that it can't, because I think that's quite nice. I think there's something incredibly human. I don't know what it is, and I'm not an evolutionary biologist. It'd be nice to know what is it about the human brain that allows us to abstract. And our current AI algorithms, whether they are causal or not, cannot do that abstraction. And people talk about transfer learning and all this sort of stuff, but it's so Mickey Mouse by comparison to what humans can do. So is that
Thank you, Sally.
an answer? Yeah.
Amongst that answer, I heard a call for more money for research. That's what I heard. Lyria, I'm going to throw it to you. Last question that I'm going to make, and then we'll open up to the panel. After this. Lyria, last question for you. Just imagine that Sally did stick at it for another 10, 20, 30, 100 years and came up with a much better model of how the brain works by using complementary technologies and improving models of AI. What would be the implications, do you think, if we did actually develop a better sense of self, a better model of self, a better model of how the brain actually works through various different techniques? What implications might that have, for example, in the world of law?
Well, that's really the question, right? Like, as in, what is it? If it's not intelligence, and I really don't think intelligence can be the right word for what we're talking about in all contexts. If it's not intelligence or only intelligence, what are we looking for in systems to perform any human task? And that might be, I gave the example of a judge. There's obviously in law, there's a whole bunch of other roles when people go to someone for legal advice and so forth. But any role, we need to work out what it is. Because until we work out, is it just sense of self, or is there some other component? And I don't know the answer to that, but I think it's a question that I hope people are thinking about.
Great, thank you. Do we have time for a question down here? Got someone right here?
Can I ask, Lyria, as an experimental scientist, it would seem to me quite reasonable at the moment to feed a computer of all the laws of the land and then get it to listen to what's going on in court, make a judgment and compare it with the judgment that's actually been made, and to see whether they are reasonable or totally different.
So that's the test that Lyria, an academic, has put up, right? That the way to know when we can have these systems be judges is to, do the blind test, right? Output the judgments of the human judges, output the judgments of the system, and when an observer can't tell the difference or even thinks the system ones are better, then you switch them over, right? That is a logical point. My question is that right? Is that all we're looking for?
We might just get one more question in before we have to go.
Given that a lot of the algorithms that we are talking about here, ChatGPT, human pattern recognition, machine vision, et cetera, have all been sort of developed using neural networks that were originally sort of inspired by the brain. And as these things have become, quite capable, does that give us any insights into how the brain actually operates? Because listening to the sort of structure of the brain being described this morning, it still strikes me that we have a very poor understanding of the actual mechanism by which all the neurons do these sorts of computations.
While not being an expert in brain science at all, I will say that perhaps the biggest con I think that has ever been levelled is the idea that a neural network, as it's known in machine learning, has anything to do with the synapses that go on in the brain, other than that they're just drawn with a circle and arrows going in and out. So I think no. I think that learning about neural networks is not going... doing artificial intelligence or understanding electric patterns in the brain, understanding what triggers certain things, running experiments, that will help us learn about the brain. And in that way, artificial intelligence, I think, can help us learn about any experimental science. Will the structure of neural networks help us learn about the structure of the brain? I don't think so.
Great. We are very close to being on time. Stella, if you had a small comment just to add to that.
I just wanted to add to that. I think it's fascinating how our obsession with uncovering ourselves and how our brains work is actually biasing quite often the naming used in AI and how we design AI. There's also AI models that are being inspired by the way ant hives move, but they're not getting the headlines. It's always the anthropomorphisms that get the headlines. So just an interesting observation there.
Thank you. Thank you. It's not called applied stats. You heard it here first. Please join me in thanking our panel.